Okay, for day one, we're going to be looking at equations of lines, absolute value, solving absolute value inequalities, and piecewise functions. So for this first formula for the slope, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or sometimes people like to write delta y over delta x. Basically, the change in the y values over the change in the x values. Point slope form of a line. Some people know it as y minus y sub 1 equals mx minus x sub 1. That's probably what you would see in most textbooks. Or some math teachers will use y minus k equals m parenthesis x minus h. But this first one is more universal, and you just need to know that you're going to fill in for the y sub 1, the m, and the x sub 1. So I'll say fill in for these. Slope-intercept form is the y equals mx plus b form that you're probably very familiar with from, Algebra 1 when you're graphing lines. When I would really use that form is if I'm writing an equation of a line, is if they specifically give me the y-intercept and the slope. If they give me the y-intercept as opposed to any other point, then I would use y equals mx plus b. Standard form, we're actually not going to even worry about that. Vertical lines, x equals c, where c is some constant. We'll put that in a minute. Horizontal, y equals c. So this is where c is a constant. Parallel lines, we need to know have the same slope, perpendicular, negative, reciprocal slopes. Or sometimes people say opposite reciprocal. But same thing. You negate the sign and then you flip it. So it's two things, negative, reciprocal. Okay, so point slope form equation of the line with the given slope through the given point. Okay, so point slope is where you go y minus the y coordinate equals m parenthesis x minus the x coordinate. And then, of course, I would not write minus and negative, so this really would look like that. And you can go right to that second step. I just wanted to show for the sake of your notes. Now for slope-intercept form, if I already did point slope form, and let's say I wanted slope-intercept form, I probably would never make you go to slope-intercept form from here, but it's a nice review of algebra skills. So what I would do is I'd multiply both sides by 2. Now the reason I'm multiplying by 2 is because I want to get rid of the 2 in the denominator here. And just to kind of, because sometimes people don't know what to do here. They're like, well, do I distribute the 2 to the x or what do I do? So you got to think about it. If you're multiplying 3 things, so 2 times 3/2 times the x plus 4. When you're multiplying 3 things, you multiply the first 2, you get your answer, and then when you get your answer, you multiply it times the third one. So that's exactly what we would do. We would, that was negative 3/2. Okay. We would multiply these 2, which means I could reduce the 2's, and then the negative 3 is what would get distributed. So this is 2y minus 14, negative 3x minus 12. Then point slope form, you solve for y. So I would then add 14. I would have 2y equals negative 3x, and then negative 12 plus 14 is a positive 2. And then I would divide by 2 and get y equals negative 3/2 x plus 1. So in this case, the slope is negative 3/2, which we already knew. But in this case, it tells me the y-intercept is 1. So that's one way of finding a y-intercept, is getting it into y equals mx plus b form. And then the b is the y-intercept, or, we'll look later at another way to find a y-intercept. Okay, so parallel to your equation through the point to negative 5. Okay, so parallel means we should have the same slope. And then through to negative 5, so it's y minus negative 5. So if you want to go right to plus 5, equals negative 3/2 x minus 2. So it's passing through that point, but with the same slope. Perpendicular to the equation through point Q, which again is 2, negative 5. That just means slope of perpendicular is positive 2/3. So y minus y equals, now the m is the 2/3, positive 2/3, x minus the x. So same equation, you just have to have the negative reciprocal slope. Now the only difference with this next one is they don't give you the slope, they give you the 2 points. So you have to do an extra step where you're going to find the slope. So you have to use your slope formula, y minus the other y over x minus the other x. So that would be 2, and that would be 5. So 2/5 is the slope. And then now you have your choice of, whether you want to, which point you want to use. So one person might say, I'm going to use this point, and then they'd have y minus the y equals m parenthesis x minus the x. Somebody else might say, no, I'm going to use the other point. So you have to pick one point to use. So you could have either or as your answer. You pick one point and you use that x and y. You can't use an x from one point and a y from another. So you have to use the same point. If you solve these for y, if you got them in y equals mx plus b form, you would see that they're the exact same equation. So here they just look a little different, but they're the exact same. I don't even think we'll bother with slope intercept, because we're normally just going to leave it in point slope unless they specifically give me the y-intercept. Equation of a line parallel, that'll just be the same slope passing through this point. So y minus the y, keep the same slope, x minus the x. Perpendicular just means use negative reciprocal slope. So negative 5/2 x minus 7. Okay, x-intercept, y-intercepts. Now, the y-intercept, we said before, we could solve this equation for y to get the y-intercept. But another way to do it, to get an x-intercept, we're going to say let y equals 0. That's what an x-intercept is. An x-intercept is where a line crosses the x-axis. So that means its y value is 0. So you would just, into the equation, you're going to plug in y is 0, which then gives you x is 3/2. So that's your x-intercept. Your y-intercept, to get a y-intercept, you're going to let x equal 0. And so into the equation, you're going to plug in x is 0 and then solve for y. Some properties of absolute values. Absolute value of a negative a is the same as the absolute value of a, right? Absolute value means distance a number is from 0. So whether it's negative or it's positive, it's the same number of places from 0. Absolute value of a product is equivalent to the absolute value of each individual factor. Then multiplied together. So you can take the absolute value of each A and B and then multiply those together. Same thing if you got absolute value of a quotient, it's the absolute value of A over the absolute value of B. They obviously say B cannot be 0 because your fraction would be undefined. And the absolute value of a sum has to be less than or equal to the absolute value of each individual term and then added together. Now, solve the following absolute value inequalities. Okay, so this is where you might remember you take what's in the absolute value bar and I always kind of call it, you sandwich it in the middle of the 6 and the negative 6. So the opposite sign of what's over here, which is negative 6 or positive 6. And if it's less than or equal to, which is really what we use. We use this in something we do a little bit later, so that's why I'm reviewing it now. And we're going to solve basically like two inequalities at the same time. So what I would do is I would go minus 5, minus 5, minus 5. Just to go back, and so what I'm saying is x plus 5 is greater than negative 6, less than 6. So it's kind of like some people have probably done it in the past where they've, when they've put it with the negative or the opposite sign, then they've switched this around. The only reason I don't do it this way is because you have to know it's and, not an or. So I keep it the sandwich method if it's an and, which less than or equal to are and. So see, if I were giving this answer in interval notation, I would say negative 11 to 1. This one, we're going to take 3x plus 1 over 4. We're going to sandwich it in the middle of negative 5 and 5. So first thing I would do if I'm solving that is I would multiply by 4 to get rid of the 4 in the denominator. So I'd have 3x plus 1 less than or equal to 20, greater than or equal to negative 20. And then from there, I would minus 1, minus 1. Negative 21 is less than or equal to 3x, which is less than or equal to 19. And then finally, I would divide by 3. So my answer would be negative 7 is less than or equal to x, which is less than or equal to 19/3. So hard bracket negative 7 to 19/3. Okay, next one, 3x minus 15 would be less than, and I'm going to make this, so this is 0.05, which is 5/100ths, right? Tenths, hundredths. So this is 5/100ths. So this would be negative 5/100ths. I'm going to show you something that we're going to use later in the year, which is we are going to look at taking out the 3. here. Maybe that makes it a little more confusing. Never mind. Okay. So we would basically add 15 . Oh, you know what? I'm going to scrap this. I know what I wanted to show. So I wanted to show, I'm sorry, I wanted to show from the beginning. This can be written like this. The 3, since it's a constant, so I'm going back up to this, the absolute value of A times the absolute value of B. The absolute value of A, absolute value of 3 is 3. Absolute value of x minus 5 has to be written absolute value of x minus 5. Now, to get rid of the 3, I can multiply by a third. And I'd have the absolute value of x minus 5 is less than 5 over 300. Now, I could take that x minus 5 and sandwich it in the middle of 5 over 300, negative 5 over 300. And then you would just add 5, add 5. Okay, so 5 would be what, 1500 300ths? So this would be 1505 over 300. And if that was 1500 300ths, it'd be what, 1495 over 300. Okay, so for graphing the piecewise function, f of x, which is y, is equal to x minus 2 if x is greater than 3. Sometimes people like to do charts for the piecewise functions. You don't have to. So x is greater than 3, greater than or equal to 3 means we start with 3, greater than 4, 5. And then we're going to put 3 in for x. 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. Because remember, f of x is y. So whatever we put in for x, it's spitting out a y value. So if I made a graph here, oops. Okay, 1, 2, 3, 1, 4, 2, 5, 3, and that is just a line because x, right, linear function. Next one is also a line. Now we're doing x is less than 3. Less than 3 does mean we start at 3, but with an open circle. And I might pick, so let's see, negative 3 over 3, right? If I put 3 in for x, that's negative 3 over 3 plus 4. So it's negative 1 plus 4, which is 3. If I put in, now obviously if I put in 4, 5, those are not going to be nice numbers. So I might go to 6 next. Negative 6 over 3 plus 4. Negative 2 plus 4 is 2. So 3, 3. We should have an open circle. 1, 2, 3. 1, 2, 3. Open circle. And then it's 6. Oh, I'm sorry. Less than 3. Why did I do 6? Oh, not doing well here. Okay. So less than 3. So I'd have to go, if I go less than 3, 2 is not going to be a nice number. 1's not going to be a nice number. 0, that'd be negative 0 over 3 plus 4, which would be 0 plus 4 or 4. So 0, 1, 2, 3, 4. And then you could really continue the pattern, right? It's down 1, right 1, 2, 3, or that's up 1, left 1, 2, 3 for the slope. So if you wanted to get another point, you could do it like that. Up 1, left 1, 2, 3, that type of thing. And then this is also a line. Oops. It's hard to draw a line on here. But there's your line. Now, part of the reason I knew when I had the 6 that I was wrong, because if I go over 6, it'd be over here. My line would be kind of crossing over this line. And remember, functions have to pass the vertical line test. So if you draw something and it doesn't pass the vertical line test, you know you made a mistake because it's a piecewise function. Functions have to pass the vertical line test. So a good point to make there. Okay. So the next one, and again, you don't necessarily have to do a table of values, but I don't know if you want to. Less than 1 means you start at 1 with an open circle, then go less than 1, so 0, negative 1. 1 minus 3 is negative 2, but the absolute value would be 2. 0 minus 3 is negative 3, the absolute value is 3. And then negative 4, but the absolute value is positive 4. Okay, so 1, 2, open circle, 0, 3, negative 1, 4. And that's an absolute value function, which looks like a V. So we're just getting this part of the V. We're just getting, so it is almost like a line, but it's really your absolute value function, which is usually a V like that. We've got a 4th root equation. So now if I do that, equals 1. Oh, well, equals 1. So that's just going to be a point, right? So I can say this is a point, 1 comma something. 1 minus 1 is 0. 0 to the 4th is 0. So 1, 0 right there. So then for this one, greater than 1 does mean I start at 1, but with an open circle. This would be square root of 4, which is 2. Greater than 1, if I put in 2, that's going to be radical 8, not a nice number. If I put 3 in, that'll be radical 12, which is not a nice number. But if I put 4 in, that would be radical 16, which is 4. That's a better number. 1, 2. So 1, 2, 3, 4. 1, 2, 3, 4. Now a 4th root, or I mean a to the 4th, or I'm sorry, I'm looking at the last one to the 4th. A square root function. Square root function is going to look like that. Notice this does pass the vertical line test. So we know we're on the right track with that. Okay, so this wants you to write the piecewise function. So you could say f of x equals, so let's see, this looks like a line going down 1, right 1, down 1, right 1, down 1, right 1. So that's got a negative 1 slope. Let's see where the y-intercept would be if I continue up 1, left 1, up 1, left 1. The y-intercept would be at 3. But we're only doing this if x is greater than or equal to 2. And then the next one kind of looks like it could be a parabola shifted up 1 because it's going through 1. So that'd be x squared plus 1. And we're doing that if x is less than 2. Okay, now taking that same piecewise function we had back in example 5, and if I want to figure out f of 1, I got to look which of these intervals has an x value of 1, only the middle one. So that's what I want to substitute in to. F of 3, which interval would have 3 in it? Well, greater than 1, this interval. So this would be square root of 4 times 3, square root of 12, or if you want to break it down, that's radical 4, radical 3, which is 2 radical 3, which you can kind of see from back here also. And negative 3 would be less than 1, so you'd be plugging in for that top equation, getting absolute value of negative 6, which is 6. And then finally, graph the function f of x equals the absolute value of x, or the graph can be obtained by graphing the two parts of the equation. Okay, f of x equals x, where x is greater than 0. So if you think about it, y equals x, that's generally, straight line going through 0, 0 and all the corners. But you're only graphing when x is greater than or equal to 0. So you're going through 0, 0, 1, 1, 2, 2, that type of thing. And then for the next one, you're going through negative 1, 1, negative 2, 2, right? If you put negative 2 in there, it's negative negative 2, which is 2. So it shows that your absolute value is really like a piecewise function that looks like that. That could make your absolute value function. Okay, that's it for day 1.